this video, we're going to be talking about imaginary numbers. And imaginary numbers are always going to include the letter I to signify I for imaginary. So let's go ahead and talk about this letter I before we look at our examples. So what is an imaginary number? Well, if we try to multiply two numbers together with the same sign, we're never going to get a negative number. So for example, if we multiply 2 by 2, we're going to get positive 4. We had a positive times a positive, we got a positive number. If we do negative 3 times a negative 3, we're going to get a positive 9. If we do 0 times 0, we're going to get 0. If we do negative 1/2 by negative 1/2, we're going to get a positive 1/4. So what we realize is that no matter what number we pick, when we square that number, we're always going to get a number that's 0 or positive. We can take 0 squared, we can take a positive number squared, we can take a negative number squared. We're always going to get 0 or a positive number. We can never get a negative number. So why is that a problem? Well, most of the time it's not. But what if we want to find the square root of something like negative 9? Looking at these examples, we would just say that if we take the square root of 4, we get 2. If we take the square root of 9, we can get negative 3, or we can get positive 3. If we take the square root of 0, we're still going to get 0. If we take the square root of 1/4, we're going to get positive 1/2 or negative 1/2. But what if we want to take the square root of a negative number? It seems like it's impossible to do it. So here's how we solve that problem. We know the radical rule that tells us that the square root of AB, in other words, we have two numbers A and B multiplied together, that's going to be equal to the square root of A times the square root of B. In other words, we can separate A and B into their own square roots. So we're going to say that the square root of negative 9 is the same thing as the square root of negative 1 times 9, right? We haven't changed anything. Negative 1 times 9 is still negative 9, but we've separated this into two numbers. Then we can say, according to this square root rule here, that the square root of negative 1 times 9 is the same thing as the square root of negative 1 times the square root of 9. So now they're in their own square roots. We know that the square root of positive 9 is definitely 3. That's really easy. So now we have 3 times the square root of negative 1. And this is where a mathematician named Euler came up with an easy way to express this value. He called the square root of negative 1 I, so he simplified this value here, 3 times the square root of negative 1. Since the square root of negative 1 is I, he just called this 3I. So this then becomes a way for us to find the square root of a negative number. And now we say that the imaginary number I is equal to the square root of negative 1, and that I squared is equal to negative 1, because when we take the square of both sides here, when we square both sides, we're going to get I times I on the left, which gives us I squared, and the square root of negative 1 times the square root of negative 1, which is a negative number, it's negative 1. So we take these two values for granted now, and we can use them to simplify imaginary expressions. So what do we do when we have imaginary expressions like these ones? Well, this first one here, we have 2 times I. Well, we can rewrite this as 2I squared. Then we have minus 3 times I, so we can say minus 3I cubed. We'll want to write it as I squared times I. I squared times I is the same thing as I cubed. We've got 3 i's here, so we say minus 3I squared I plus 2I minus 4 minus the square root of negative 4. Now, how can we use these definitions for imaginary numbers to simplify this? Well, we know that I squared is equal to negative 1. So instead of I squared right here, we can plug in negative 1. So we'll get 2 times negative 1. Here we'll get minus 3 times I squared. We know I squared is negative 1. So minus 3 times negative 1 times I plus 2I minus 4. And then here for the square root, we can say minus the square root. Remember, negative 4 is the same thing as negative 1 times 4. So we'll say 4 times negative 1, like this. And now 2 times negative 1 gives us negative 2. Negative 3 times a negative 1 gives us a positive 3, and we leave that I. Then we have plus 2I minus 4. Now for our square roots, we can break this up into minus the square root of 4 times the square root of negative 1. We'll combine a few like terms here. We have a negative 2 and a negative 4. That gives us a negative 6. We have a 3I and a 2I. That gives us a positive 5I. Then we have minus the square root of 4 is 2, so we get 2 here. And then the square root of negative 1 we've defined as I, so we multiply that and we get minus 2I. Then combining like terms again, we get negative 6, positive 5I, and a negative 2I gives us a positive 3I. And that's our final answer. And it's really important. We always want to, when we're dealing with imaginary numbers, leave the answer in this form, meaning the whole number first, whether it's positive or negative, but the whole number first, and then the imaginary number second. So followed by the imaginary number. And the imaginary number might have a coefficient. In this case, it has the coefficient 3, but whole number and then imaginary number. Let's do a second example here. We have 3i cubed. We're going to change that to 3i squared times I. We're going to have plus 2i squared. We know I squared is -1, so we'll get plus 2 times -1 plus 7i plus 4. And then here for 2i to the 5th, we'll change that to plus 2 times I squared I. Simplifying again, we have I squared here. We know that's -1, so we get 3 times -1 times I. 2 times a -1 is a -2 plus 7i plus 4. And then here we have plus 2 times I squared, so times -1 times -1, and then that final I there. 3 times -1 is a -3i, minus 2 plus 7i plus 4. And then we have a -1 times a -1 will give us a +1. +1 times 2 is a +2, so we just get plus 2i. Now we combine our like terms. We want our whole numbers first, so we have a -2 here and a +4. That'll give us a +2. That'll take care of these two. Then we have a -3i plus a 7i is going to give us a +4i. Plus 2i is going to leave us with a +6i, so we say plus 6i. And this will be our final answer with the whole number first and then the imaginary number second with the coefficient of 6. So the final answer is 2 plus 6i, and that's how you simplify imaginary expressions.